In the shadows of complexity, we find clarity. This is NebTech. Welcome to my channel. The birth of a Pictionary. It was a beautiful spring morning when four of us in 2014, self-taught developers with more confidence than sense, decided to revolutionize the world with our startup, Pictionary. Our mission was simple yet ambitious. Build an API service that would seamlessly connect any two systems on the planet. APIs are just fancy pipes, I remember Frank saying as he sketched our architecture on the back of a pizza box. How hard could it be? Oh, the naivete of youth. Our seed funding came from a venture capitalist who had made his fortune in toilet paper during the SARS pandemic. "I'm flush with cash," he joked during our pitch meeting, "and I'm looking to invest in something that won't get wiped out." His laughter haunts me to this day. The contract that promised everything. Our first API contract was a thing of beauty. 73 pages of meticulously documented endpoints, response codes, and data structures. We'd anticipated every edge case, documented every parameter, and even included a flowchart showing the life cycle of an API call that my mother framed and hung in her living room. "My son, the architect," she would tell her bridge club. The contract promised clean JSON responses, predictable error codes, and most importantly, stability. We boldly stated in bright red text, "This API will maintain backward compatibility until the heat death of the universe, or our Series B funding, whichever comes first." We launched with 6 enterprise clients who paid us actual money. Life was good. The first sign of trouble. 3 months in, we received our first support ticket. "Your API returned the user list in alphabetical order yesterday, but reverse chronological order today. My recommendation engine is now suggesting funeral homes to newborns. Please fix ASAP." I checked our contract. Nowhere did it specify the order of items in list responses. I smugly composed a reply citing section 5.7.2, which explicitly stated, "The order of elements in returned arrays is undefined and subject to change." The client's response was immediate. "We've built our entire user experience around the alphabetical ordering we observed during the first 2 months. Changing now would cost us $175,000 in development work. Fix it or we're invoking the SLA penalty clause." And thus, I discovered Hiram's law the hard way. With a sufficient number of users of an API, it does not matter what you promise in the contract. All observable behaviors of your system will be depended on by somebody. The undocumented feature that saved Christmas. As we scrambled to fix the ordering issue, we discovered something strange. A developer had added an undocumented parameter. _debug equals true that when present would output detailed timing information in the response headers. We hadn't documented it because it was meant for internal use only. To our horror, we found that 3 of our 6 clients were using this parameter in production. One had built an entire performance monitoring dashboard around it. Another was using the precise nanosecond timestamps to synchronize operations across their distributed system. The third refused to tell us how they were using it, only that removing it would unleash the apocalypse. The great refactoring. That wasn't 6 months in, our backend was a mess. The codebase resembled a plate of spaghetti that had been thrown against the wall, then left to dry for a week. We needed to refactor desperately. "It'll be fine," said our team lead, Mark. "We'll do it over the weekend. No one will notice." We spent 2 weeks planning the great refactoring. We would replace our MongoDB with PostgreSQL, our synchronous code with async, and our handcrafted JSON parsing with a proper library. None of these changes would affect the API contract, of course. The inputs and outputs would remain identical. What could possibly go wrong? The refactoring went smoothly. Our tests passed. Our documentation remained valid. We deployed on a Sunday night and went to bed, dreaming of clean code and efficient database queries. Monday morning, our monitoring system resembled a Christmas tree. If all the lights were red and each one represented a client screaming in digital agony. It turned out that one client was depending on the exact whitespace formatting of our JSON responses for their parser to work correctly. Another was using the response time as a random seed for a cryptographic function. A third had written a parser that expected our error messages to always be exactly 83 characters. The fourth was scraping the HTML from our error pages instead of parsing the JSON. The fifth had built a system that failed if responses came back too quickly, which our new optimized backend now did. The sixth client hadn't noticed any issues because they weren't actually using our API. They'd been paying us for 6 months while still implementing their integration. The versioning that solved nothing. We need API versioning, declared our product manager, Sophia, after the refactoring fiasco. That's what mature companies do. So we introduced /v1/in to our endpoints and promised that this would solve all future compatibility issues. When we needed to make changes, we'd simply increment the version number. Simple. 3 weeks later, we rolled out V2 with some minor improvements and optimizations. None of our clients migrated to it. 3 months later, we rolled out /v3/ with significant performance improvements and new features. One client migrated. 6 months later, we were maintaining 5 different API versions, each with its own quirks and bugs. Our codebase looked like an archaeological dig site with layers of different development eras preserved for posterity. The documentation that lied. Our API documentation was our pride and joy. Auto-generated from code comments, beautifully rendered, and always up to date. Except when it wasn't. It turned out that our auto-documentation tool had a bug. It wouldn't detect changes in response structure if they occurred inside conditional code paths. So our docs confidently stated that a specific endpoint always returned a user ID field, when in fact it sometimes returned a user ID field instead, depending on which authentication provider was being used. We discovered this only after a client built an entire user management system around the documented field name, only to find that 30% of their users couldn't be properly identified. When confronted with this discrepancy, our documentation proudly displayed the following note that I had added months earlier. This documentation is definitive and comprehensive. Any behavior not documented here should be considered a bug and not relied upon. The client printed this statement, framed it, and sent it to us with a note. If a tree falls in a forest and no one documents it, does it still break my production system? The accidental breakthrough. 8 months into Apictionary's journey, we were on the verge of collapse. Our clients were unhappy, our codebase was a nightmare, and our VC was asking uncomfortable questions about burn rate and runway. In desperation, we tried something radical. Honesty. We admitted to our clients that we couldn't predict every way they might use our API. We asked them to tell us what behaviors they depended on that weren't in the contract. We created a client dependency registry where they could document the unofficial behaviors they relied upon. To our surprise, they were mostly reasonable. They understood that they had built on quicksand in some cases. Some even admitted they knew they were depending on undocumented behaviors but had deadlines to meet. Together, we developed a new kind of contract. Instead of promising that nothing would change, we promised transparency about what might change. We established clear communication channels, deprecation periods, and migration assistance. We set up a behavior dependency scanner that would automatically detect when clients were relying on patterns not covered in the contract. The moral of the story. 3 years later, Apictionary is still around. We didn't become unicorns, but we found a sustainable business model built on trust and realistic expectations. Our API has evolved significantly, but in a controlled manner that brings our clients along for the journey. The great irony? The more clearly we communicated what might change, the more our clients trusted that we would help them manage that change. The more we acknowledged the reality of Hiram's law, the more flexibility we actually had to evolve our API. Our experience taught us a fundamental truth of API design. The contract you write is not the contract your users follow. The real contract is the sum total of all observable behaviors, whether you intended them or not. As an API owner, your job isn't to prevent change, it's to manage it. You can gain flexibility and freedom not just by being clear about interface promises, but by acknowledging the messy reality that users will find utility in behaviors you never imagined were important. In the end, the most important documentation isn't about what your API does. It's about how you'll handle the inevitable evolution of what it does. And if you think your API contract will protect you from the chaos of user dependencies, I have a lovely bridge API to sell you. It connects Manhattan to Brooklyn, returns results in alphabetical order, except on Tuesdays, and is guaranteed never to change until it does. What begins in shadows ends in understanding. You've been watching NebTech. If you found value here, please consider liking and subscribing. It means a lot and helps the channel grow.